Hello, and welcome to another E2 tutorial session today. We will be looking at basic time series methods, very simple methods to help you understand time series analysis. Basically, a time series analysis is a statistical technique used to analyze and model data points collected over a specific time interval, right? So when we say time interval, we're looking at seconds, minutes, hours, days, months, quarter, year, and so on, right? Time intervals. So, and we're using these time intervals to try to identify patterns, trends, seasonal variations, so that we can forecast what future values will be and use that future values to make certain decisions. So that is what time series analysis is all about. So for today, as I mentioned, we're looking at very basic time series methods. And the very four methods we will start with is the naive forecasting method, the moving average, exponential smoothing, and finally the linear trend analysis, which is just how do you use linear regression to do a time series um, forecasting. So we'll go through this four different methods using three examples that we have today. But in this first part, we'll focus on the naive forecasting. What is naive forecasting, right? Um, it basically assumes the most recent actual value is the best predictor for the next period, right? Um, with no adjustments for trends or seasonality. So this method is like beginner method, right? There's no complex analysis being done here or whatsoever, right? It just takes the most recent actual value and tries to use it to predict what the value for the next month or the next week or the next year will be. That's what the naive forecasting method um, is. So, having said that, let's look at our first example and we'll try to do all of this analysis using R. So please make sure you have your R opened up and ready to go. The other thing I would also mention is when doing forecasting, we have different types of performance metrics we use to kind of gauge if our model is performing well or not. One of that, one of such metrics is called the MSE, which means the mean squared error. There's another one called the mean absolute percentage error. There's also the mean um, absolute error, right? Different types of metrics that we could use to see if our model is performing well or not. I think the goal there is just like regression, we want to try to minimize the error. In forecasting, the goal is to minimize the forecast error. So we tend to look for which metric has the lowest um, error, right? So, but for this first example, we're only focusing on the mean square error. So we can see that this is sales of a tonic from Roscoe stores, and we're given this sales from a 10-week period, right? And we're asked to create the naive forecast method based on weeks 2 to 10 and then calculate what the MSE value will be. So let's jump into um, R and start working on this. All right, so I would just have this as method one. So please let me zoom in so that everybody can see my screen properly. All right, so I think I'm properly zoomed in. So method one would start with the naive approach. And let's put I'm just going to copy our data set in there so I don't have to type it again. All right, so this is our data set, right? So the week 1 to 10, which is what you have here, week 1 to 10, and then the value is 110 for week 1, 120 for week 4, 130 for week 10, right? That's all of the sales from the store for each of those weeks. Maybe we could change this and we could call it if you like, you can call it sales, right? Or you could just leave it as values. So I would change it and I would call it sales, right? So for the naive approach, I will go through two different methods of doing the naive approach, right? The first one is the one I explained in the definition I gave, which is using the most recent value as forecast. So I'll just say part A, most recent value as forecast. So let's do this. So we'll just say forecast A. I'm kind of using that uh, because I'm going to do two different methods in the naive approach. I am calling my forecast for part A, right, which is this part A here. So, sorry, no, no, no. This should be, I just forgot that I changed it. So this should be sales, which is what I'm interested in. So this is going to be my dependent variable, which is Y, and this would be our independent variable. But in this case, it is going to be time values, right? So week 1, 2, 3, 4, 5. So let's just put a comment there. Um, and then this is our dependent variable. All right, so sales, I want to subtract. So basically what I want to do is to exclude the sales from the last month. All right, so the sales from the last month. So this excludes the last value. So basically this 130 will not be there when we're trying to do the forecast, right? And then for the actual, so we exclude, so here we exclude the first sale, right? So let me just call it last sale, first sale, right? So we exclude the last sale in line 8, which is 130. And then we also exclude the first sale, which is 110, right? So basically, we would just be working with the values in here, right, for our forecasting. Now, let us bring our performance metric, which is the mean square error. So I'm putting that because all of that is tied to part A. So I'm always going to put that underscore A, which lets you know that we're solving just for part A, right? So the MSE is just the average, right? Um, so the equation we need for the MSE is the actual value subtracted from the forecast, and you take the square of it. So it's going to be this subtracted. So line 9 subtracted from line 8, and then you take the square. So actual A subtracted from forecast A, then you take the square of that, right? Now we get our MSE. So let's run it. So just start from there. You know what? I'm just going to start from there. So that's that. Okay, so it says my sales is not found. Oh, that's because I ran it too quickly. What is going on here? All right, so we would always get errors. So, oh, here's the problem. I shouldn't have put that dash there. I didn't put the comment properly. Okay, good. So now we have our sales there, right? So that dash was the issue. I don't know how it got in there, but please delete it from your code, right? This dash was what was causing the issue, but delete it from your code. So All right. Now we can run our part. We can run. All right. So that's our forecast there. So you can see it's excluded the last sale, and then in line 9, we exclude the first sale. Now we can calculate our MSE. So we get our MSE as 105, right? So that's our mean square error is 105, right? 0.56. So that is our mean square error. Okay, having done that, let us go ahead because our question is asking us, let's see, let's try to do a forecast on week 11 and see what it will give us. So let's let me put the so uh, mean square error is 105.56. Okay, so let's forecast um for week 11. So forecast week 11. So remember, I'm always putting A because we're talking about part A, right? So that would be tail bracket sales. So remember from our definition of the most recent value approach, which just says it uses the previous week as the forecast for the new week, right? So this would just be forecast week 11A. That's all. It's basically so simple and very easy. So 130, right? That's basically what it is. So for our interpretation for that, we could just say um, right, is 130. So that's it for part A, right? Now, the second part of another part of naive forecasting method is this. So part B, it's called the average of all data as forecast, right? The first one, we just use the data like that to do our forecast. The second one, we're trying to take the average of the data, right? And using that average as our forecast. So we're still going to be working with the data in line number 4 and 5, right? So I am not going to try and write line number 4 and 5 again because it's still the same data set. We're still talking about the naive method, but just in case you missed that, I'll put it here as a as a note, right? Okay, so I have that there. So let's go ahead and build our average of all data as forecast model. So we need to take the cumulative averages, and we use the function cumsum because it takes the cumulative um, averages of each week, right? That's basically what um, it does. So we have our sales, and then we want to exclude the last sale, right? And then we divide it by right? The cell that comes before it. So that's -1, right? So that's basically what we're doing there. So we take the, so what we would do, let's see if I can show that to you. So what we're doing in line 21 is, first off here, we exclude 110, right? In your first forecast, you would exclude 110. Now, in the second forecast, what we would do in the second forecast is that we would say 110 plus 115 divided by 2, right? That would now give you your forecast, your second forecast. So first, if we let's say your initial forecast, you would exclude 110. There would be no forecast there. It would just be like a zero value. And then your forecast two, right, would not be 110. That would be your forecast two. Your forecast three would be 110 plus 115 divided by 2, right? That's going to be your focus 3. And then we keep going, like doing it like that. So I would show you what it looks like um, when it creates the data frame, when I run that line of code. So just be a little bit patient. I think we're already there, so I could show that to you in the next line. So let's run this. Okay, so yeah, so you can see it here, right? Let me show you. So remember, we had for week one, you have 110, 115, and so on, right? So now we've reduced it from 10 rows to 9, right? So we had 10 data points here, but here you have 9 data points because it's taking the cumulative averages, right? So your first forecast would just be 110. The next one would be 110 plus 115 divided by 2. That gives you 112, right? Then the next one, which is the 116, would now be 115 plus 1125. Oops. No, sorry, I think I made that wrong. So 110 plus 115 plus 125 divided by 3. Yeah, which gives you 116. So you're basically going to add the first 3 and divide it by 3. That gives you 116. So you just keep doing that. Then you bring in the next one, divide by 4, which gives you 117. So that's basically what the average of all, oh sorry, the cumulative averages. That's basically what it's doing. So now we have our forecast B. Remember, we said focus A was only for part A, but now focus B is for part B. And would save that as our cumulative averages. And then we have our actual, which is our actual B. Now, we're not using actual A, right? We're using actual B, which is the sales, exclude that one, right? Exclude the first value. Still the same process with actual A, right? So, and then the next thing we would do is to find our MSE, but this time we're still taking the mean and subtracting, same process we did in the first one. So actual B minus forecast B, and then you take the square of that, right? So your answer there would be your MSE. So let's run this. All right, so our MSE is 69.23. So I'm just going to copy this here and just bring it down here. 69.23, right? So if we want to also do the forecast, I'm just going to copy this so I don't have to write it twice. So forecast for sales 11. The difference here would be that I would take the mean. This should be B. Please make sure you change that. And then you take this one out. We don't need the sales comma one there anymore. So that's that. So here we're taking the average of all weeks as forecast for week 11. Hence the name, right? The name says average of all the data as the forecast. So the average of all the data would be our forecast for the next week. All right, so if we run that, we get this, we have it as a 120, right? So the number of tonic bottles projected to be sold is 120, right? Finally, I would like to just do a last part, just so that we can compare the two naive forecast method we've looked at, right? So we'll just say comparison. So, and just to see which one is better. Is it good if we just use the recent value or if we take the average of all the data and use that? Like which one gives us a good MSE? So, so all I'm just doing is like, it should just check it. Just use that simple if else function. Is the MSE from part A less than the MSE from part B? If it is, then just kind of tell us, right? By saying, okay, the most recent value was the best, or just say the average of all data is the best. And then it should kind of list I also wanted to list the results for us. So you see why it's important that we had that MSC as A and B, right? So that we can easily differentiate. So I think so now so this should be forecast. And then beta method this. All right. So if we run this, let's run this and see. Run. Oh, I didn't put a comma in all of these things. That's why it gave me an error. I forgot to put a comma. So R is very sensitive. All right, so there we have it. Right, so it's basically summarized everything for us. So the MSE for the part A was 105.56. And we got a forecast of 130. MSE for part B, we had it at 69, and we had a forecast of 120. And then it's letting us know that, hey, the better method is the average of all, which is part B, right? So in a nutshell, that's basically how we develop a naive forecasting method and using it to forecast the value of a future um, week. I hope this was helpful to you. If it was, please do subscribe and like the video. Also, don't forget to turn on the notification bell. Thank you for watching all the way to the end.